Okay, so we will be starting off with isomerism in coordinate compounds. So just because it's coordinate compounds in organic chemistry, there is no difference in isomerism. Whatever you have learned in organic chemistry, the exact same concepts, exact same definitions, everything remains the same. Just that instead of organic compounds, we are applying it to coordinate compounds. Okay. So what is the overall definition for isomerism? You guys only tell me. क्योंकि बचपन से we've been learning this.
The molecular formula is the same, but the structural formula differs.
Correct. So same molecular formula. When we talk about molecular formula, it means they have the same atoms in that particular complex, in that particular compound. But the way it's arranged, the structural formula will be different. Okay. And just like in the case of organic chemistry, in this case also, even in coordinate compounds, we have two different types of isomerism. We have structural isomerism and we have the second one, geometrical isomerism. The second one is geometrical, but we'll look at geometrical later. Okay, let's keep this aside for now. We'll come back to it. So pehla wala structural isomerism. So structural isomerism, it's pretty direct. The physical structure itself is different. Okay, just like how in organic chemistry you have same molecular formula, but like the arrangement of atoms itself is different. Like it could be the order of the atoms, it could be which one is bonded to what, in what capacity is bonded, like all of that. So depending on where the difference lies, the structural isomerism, further you have 4 different cases. Okay, so the first one is linkage isomerism. So linkage isomerism, you will find out, like you'll find this sort of isomerism whenever you have an ambidentate ligand. Do you guys remember what is an ambidentate ligand?
The one which has like 2 donor pairs of atoms, but it shares with only one.
Huh. So there's possibility that
Possibility is 2, but it does it with only one of them.
yes. Okay. So just like from the name itself, you can figure out ambidentate linkage isomerism matlab. So the difference in this case is like the difference is in donor atom. Donor atom of the ligand. So for example, suppose we have NiCN4, let's say. Or yeah, pretty simple. Like if we have, let's say, NiCN taken 4 times, 2 plus. So यहाँ पे cyanide is an ambidentate ligand. So either the carbon can be linked to nickel or nitrogen can be linked to nickel. So a pair of those, like, you know, a compound where carbon is linked and the compound where nitrogen is linked. So a pair of those would become they both would be linkage isomers. Okay. So if we had to do it, so CN, versus Ni, NC, 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 NC. So you can see that in this case you have, let's put the charge here. So this will be 2 plus, and this will be 2 plus. Yeah, so you can see in this case, the linked atom is nickel versus in this case, it is carbon. Okay, so this sort of a case is called, like this, what you call as linkage isomerism. Okay, let me know when you guys have noted it, and we'll look at the next one. It doesn't have to be only with this also, like you can have like heteroleptic compound also. Like another example, if you had to note it down. CO, NH3 taken twice, into Cl. And CO, 3 taken twice, ONO. So nitro was another ambientate ligand. So in this case, nitrogen is the one linked to cobalt, and in this case, oxygen is the one linked to cobalt. Smera, this should also answer your question you had yesterday. Like when it's ambientate, how do you figure which one is like? So you modify, like the way you write, you always write it with the atom that's bonded to the atom.
So the first one will be NiCN4 and the next one would be Ni and bracket NC4.
NC4, yeah, can represent it that way. Okay. Okay.
Ma'am, I had a doubt. Then this compound, what will be the shape of it, the cobalt wala thing?
Cobalt, 3 ligands hai na?
Yeah.
Is what, 26? Iron is 26. Nickel cobalt will be 28 then. 27 or 28. Iron cobalt nickel. So that again, you have to get into the electronic configuration and then figure out how it's being arranged and all of that.
Okay, because iske pehle we have not seen a 3 ligand wala compound.
Yeah, you're right. This should be NH3 thrice. I miswrote it. Usually it's 4 or 6. 3 is. Okay, just make this correction. It'll be NH3 thrice, not twice. So that's linkage isomerism. Next, we have coordination isomerism. So coordination isomerism mein, so basically it's the same molecular formula. Matlab you have the same atoms making up the formula or the compound, but in the case of coordination isomerism, the coordination entity itself will be different. Okay, so this happens when you have interchange of ligands between the cationic and anionic coordination entities. Okay, so for example, so we have, let's say, CO NH3 taken 6 times, we keep it simple, and Cr Cn taken 6 times. And if we interchange the ligands in the cation and the anion, so both of these exchange the ligands that they have. So यहाँ पे Cr will have NH3 and CO will have Cn. So overall formula is the same. It's made up of a cobalt atom, chromium atom, ammonia is the ligand, cyanide is the ligand. Same thing in both the cases. But the cation and anionic entities are exchanging the ligands, the atoms. Okay, इसमें cobalt is the cationic entity that is bonded to ammonia. In this case, chromium is the one that's bonded, like cobalt is bonded to cyanide. Like cobalt and chromium exchange their entities, the ligands that they're linked to. So this sort of an isomerism is called coordination isomerism. So another example is platinum. So PT NH3 taken 4 times and PTCl4. So isme platinum itself is like this is the like platinum itself is there in both the cation and anionic ligands. So looking at it, I mean it's yeah, this is like it's self-explanatory, right? Like if both of these exchange the ligands, that's a coordination isomer. So, okay, so this is coordination isomerism. And then the third, okay, let me know once you finish noting down the details. Let me look at the third one. Sanskriti? Yeah, okay.
Ma'am, I'm done writing.
Okay. The third one is ionization isomerism. So ionization isomerism is where, like, when it differs in the ions that it gives out in solution. Okay, so isme you have the same composition. So it's composed of the same metal atoms, ligands, and everything, but gives different ions in solution. Okay, so what this means is, like, we'll take an example. We have, let's say, CO NH3 taken 5 times SO4 Br and CO NH3 taken 5 times Br SO4. Okay. So what do you think the difference is between both these compounds?
So the ligand and ion is exchanged.
Huh. So cobalt, like if you mix this in water, you're going to get this complex as an ion, and this produces bromide ions. But in this case, you're going to have a different thing. The complex is there in the ion as an ion, and then this produces sulfate ions. Okay, so that's the difference between both of these. Yeah, so that's ionization isomerism. So it contains all the same species, but the ions that it gives out when you dissolve it in water is different. इसमें bromide ions आ रहा है, इसमें sulfate ions आ रहा है. Okay, and yeah, and you can identify both of these are different compounds because oxidation state of cobalt is changing. So this is a red colored compound and this is a blue colored compound.